Hello everyone. Today we're going to start the unit rates and proportional relationships, and we're going to start with the first skill of that unit, which is rates with fractions. So before we get into some of those problems, we're just going to go over some vocabulary that's necessary for you to know for this unit. So the first thing I want to talk about is, what is a ratio? Well, a ratio is simply just a comparison of two quantities. So as you can see in the below example, it says 5 girls to 15 boys, and then it's also rewritten again, 5 girls with, as you can see, there's a colon here, to 15 days. And then there's one last way that you can write a ratio. There's 3 different ways, one way being with the 2, another with the colon, and then the last one is simply just to write it in a fraction format, 5 over 15. So that's all a ratio is. It's just a comparison between two quantities. So let's do a few examples of writing ratios. So they said that this example says there are 198 girls and 162 boys in grade 7. Well, what is the ratio of boys to girls? That's just going to be, well, we know there's 162 boys, so I'm going to write 162, and there's 198 girls. Okay, so you have to be careful to make sure that whatever the first word is, that's your first number in your ratio, and whatever the second word is, that's the second number in your ratio. Now, if I were to write this as a fraction, it would be 162 over 198. And then over here all the way to the right, you can see it says ratio in its simplest form. So we just need to simplify 162 over 198, and let's go ahead and simplify that, and we can divide them both by several numbers. You can start with an even number if you're not sure and just keep going and going, but when you eventually simplify it all the way, it's going to simplify down to 9 out of 11. All right, in the next example it says boys to grade 7 students. Well, we know that there's 162 boys, and the total number of students would simply just be 198 plus 162, which gives us a total number of students of 360. So if I were to write that as a fraction, it would just be 162 over 360. And again, if I were to simplify that, we would just, you can either start with 2's, or if you can figure out a bigger number that goes into both, you can always do that as well. They're both, I believe, divisible by 9, so you could start with that. So that simplifies down to 9 over 20. And then the last one is girls to grade 7 students. Well, we know there's 198 girls. We know there's 360 total students. So written as a fraction, we'd have 198 over 360. And then again, if you want to go ahead and simplify that, you can, again, they're both even numbers, so you can start with 2's, or you can start with 4's or 9's, or whichever number you can find which goes into both numbers, and that's actually going to simplify down to 11 over 20. The other way you can look at it is, we're comparing two things because it's a ratio, boys and girls. So if boys were 9/20ths, that means that girls has to be 11/20ths, because what do we get when we add 9/20ths plus 11/20ths? Well, we get 20/20ths, or 1 whole. So that's another little trick you can use to determine what the other ratio will be. Okay, a rate is another word that we're going to talk about. A rate is basically the same thing as a ratio. However, it specifies the units being used. So it's a comparison between two quantities, which may be of different things. So for example, 120 miles per 2 hours, and then I've simply just written it using a colon, 120 miles with a colon for 2 hours. So it's a ratio, it's a comparison of two numbers, but because I'm using miles and hours, that's what makes it a rate, because it's two different types of things being compared. So for example, down below, 20 seconds for 10 ounces. We're comparing between seconds and ounces. And then in the next example, 80 miles per 4 hours. Again, we're using miles and hours. So it's a rate, a comparison between two quantities that are of different things. And then the last one I just want to talk about is a unit rate. A unit rate is the same thing. It's a ratio between two measurements in which the second term will always be 1. So for example, on the last slide, we did 120 miles per 2 hours. Well, if I were to write this 120 over 2, if I were to simplify this ratio, that would give me 60 miles per 1 hour. So this would be considered a unit rate, and this would be considered just a rate. So a unit rate will always be simplified down to where the second quantity is always a 1. Now, another little trick I just want to bring up is that money will always go on top. It's always going to be the numerator whenever you are finding a unit rate. So let's take a look at this example with the peanut butter. What is the unit rate for each jar of peanut butter, and which jar of peanut butter is the best buy? Well, as we just mentioned, money is always going to go on top. So I'm going to put dollars over ounces, and your abbreviation for ounces is OZ. So we're going to put $3.30 over 16. And now I'm going to go ahead and do that division step, and you can use a calculator for this step. So we're going to do 3.30 divided by 16, and that's going to give us our unit rate, which is a long number, 0.20625. However, we are finding a unit rate with money, and money always gets rounded to 2 decimal places or to the hundredths place. So if I were to round this number, my hundredths place is right here. This 6 is going to tell me what to do, and hopefully you remember the rule for rounding. 5 and above, we give it a shove. 4 and below, we let it go. So since that number in my thousandths place is a 6, that means we're going to give this 0 a shove, giving us a total unit rate of 21 cents. So let's erase this and rewrite our new unit rate. So what that means is that this jar, let's erase that. This jar of peanut butter is going to be 21 cents per ounce. Okay, so now that we've calculated that one, let's go ahead and try the one next to it. So again, we're going to do dollars over ounces. And we're going to put $8.60 on top and 64 below. So on your calculators, go ahead and divide $8.60 by 64 ounces. And again, we get a long number. We get 0.134375. So we're going to have to do rounding again. This is my hundredths place. And the number in the thousandths place tells me what to do. Again, 5 and above, we give it a shove. 4 and below, we let it go. So we're going to let it go, which means that this one is going to be 13 cents per ounce. So notice the last question asks, which one is the better buy? Well, clearly the one that is cheaper is the better buy. So your larger jar of peanut butter will be your best buy here. And that's why people go to places like Costco and Sam's Club, because you can buy things in bulk, and it tends to be cheaper than going to a regular grocery store. Okay, so let's just do one last example so that we all understand the difference between a rate and a unit rate. Remember, a unit rate gets simplified to be per 1 unit, and a rate just has 2 different types of measurements being involved. So let's take a look at the first one, $240 for 60 hours. Well, I can see that this is not simplified to 1, which means that's just a plain rate. Here we've got 95 feet per second, well, that means 95 feet per 1 second, which makes that a unit rate. 5 CDs for $40, that's going to be a rate. $1.25 a pound, well, that means per 1 pound, so that's going to go over here with unit rates. $14 per hour, that's $14 per 1 hour, so that would be a unit rate. Let's take 26 miles in 5 hours, that's going to go over here where a rate is. $15 for 12 pounds, that's not per 1, so that goes over where rate is. And then last but not least, we have 45 miles per hour. That means 45 miles per 1 hour. All right, so let's get into some rate with fractions problems. This is the first skill in this unit. Now that we know the vocabulary and the difference between rates and ratios and unit rates, let's go ahead and give this one a try. So it says Charlie reads quickly. He reads 1 3/7 pages every 2/3 minutes. How many pages does he read per minute? Well, the first thing I want you to look at is this right here. The question in your problem is going to tell you how to set it up. So we want to know how many pages per minute. And I'm going to strongly suggest that you set up the same little key here before you start your problems, because it makes it a little bit easier. So I know pages is going to go on top and minutes is going to go on the bottom. So I'm going to take my first mixed number, which is 1 3/7. That's the number of pages, and that's going to go over 2/3. And really all we have here is a fraction division problem. All we're doing is 1 3/7 divided by 2/3. And hopefully we remember that when we divide with mixed numbers, we have to convert them to an improper fraction first. So we're going to have to take this one and make it improper. So 7 times 1 is 7, plus 3 gives me 10/7, divided by 2/3. The other thing we need to remember is that when we divide with fractions, we have to keep change flip, which means we're basically just multiplying by the reciprocal. So we're going to keep our first fraction, we're going to change division to multiplication, and we're going to flip our other fraction. Now you always want to check to see if you can cross simplify on your diagonal. So we've got 3 and 7. They share no common factors, so we can't do anything there. But 2 and 10, well, they're both even numbers, which means you can divide them both by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And now we've gone ahead and cross simplified, so we can solve. 5 times 3 gives me 15 in my numerator, and 7 times 1 gives me 7. Now you can go back and convert this back to a mixed number. You don't have to, you can leave it as an improper fraction, but if you were going to make it a mixed number, 7 goes into 15 2 times, and that leaves 1 left over, so we would be left with 2 1/7. So what that means is that Charlie reads 2 1/7 pages per 1 minute. Excuse me. All right, let's try another example. Calvin cleans 3/5 of his bathroom with 1/3 of a bottle of cleaning solution. At this rate, what fraction of the bottle of cleaning solution will Calvin use to clean his entire bathroom? So the important thing to see here is we're looking for how much of the bottle of cleaning solution will he use per his 1 bathroom. So we're doing solution over bathroom. So it says he cleans 3/5 of his bathroom, and this is why we do these key words here, because the 3/5 then goes on the bottom and 1/3 goes on top. So I'm going to set up my division problem. 1/3 divided by 3/5. We have no mixed numbers here to convert, so we're simply just going to keep change flip. So we've got 1/3 times 5/3. Check your diagonals to see if you can cross simplify, which we can't. So we're just going to multiply our numerators. 1 times 5 is 5, and 3 times 3 is 9. So what that means is that he uses 5/9 of the bottle, just more than half, to clean his bathroom. Okay, let's try another one together. Corey bought 2.5 liters of paint for $60. What was the cost per liter? As we mentioned previously, if there's money involved in the problem, the money always goes on top, or the other way you can look at it is it says cost, which we're doing in dollars, per liter. So 60 is going to go on top, 2 1/2 goes on the bottom, which really means we're just doing 60 divided by 2 1/2. So I'm going to convert 2 1/2 to a mixed number. That's going to be 2 times 2 is 4, plus 1 gives me 5/2. So really we're doing 60 divided by 5/2. And hopefully we remember that when we divide with whole numbers like we have here, we simply just put them over 1 to make them a fraction. We're going to do keep, change, flip. So 60/1 times 2/5. I know that I can cross simplify with 5 and 60. 5 goes into 5 once, and 5 goes into 60 12 times. They do share that common factor. And now to find our answer, we're simply just multiplying our numerators. 12 times 2 is 24, and 1 times 1 is 1, which leaves us with our final answer of $24 per liter. Okay, it's always important to remember to label. What's nice though is in Khan Academy, they do have the labels there for you already. Let's try one last one together. Uncle Drew scored 28 points in 5 5/6 minutes during a game of basketball. How many points did he average per minute during that 5 5/6 minutes? So again, we're looking at points per minute. So we're just going to write our key. He scored 28 points in 5 5/6 minutes. So we're doing 28/1 divided by, well, let's convert this to an improper. 6 times 5 is 30, plus 5 gives me 35/6. We have to do keep, change, flip, which means we're just going to multiply by the reciprocal. Always check to see if you can cross simplify somewhere, which thinking of 28 and 35, I can actually divide both of those by 7. Oh, nope, I take that back. 7 goes into 35. So 7 goes into 28 4 times, and then 7 goes into 35 5 times. So now when we multiply, 4 times 6 gives us 20. And 1 times 5 gives us 5. And we can leave that at 4 points per minute. Oh, and I just realized that I made a mistake with my multiplication here. So let's just backtrack. 4 times 6 isn't 20. Like I said, Mrs. DeValue makes mistakes sometimes too. 4 times 6 is actually 24, which now when I go ahead and convert it, 5 goes into 24 4 times with 4 left over. So that makes our mixed number 4 4/5. So what that means is he scores 4 4/5 points per minute. Now again, either of these answers would be considered correct answers. Okay, let's try a couple more together. It says Alicia earned $84 for an 8-hour shift. What is her hourly rate? Well, we know that money goes on top, so we're going to do dollars over hours. So 84 goes on top, divided by 8. And of course you can use a calculator for this one. 84 divided by 8 gives me 10.5. So what does that mean? $10.5 per hour, but we know with money it always gets taken out to the hundredths place, which means that she earned $10.50 per 1 hour. Let's try the one below it. Mrs. Douglas, Alicia's mom, teaches math at a school that has 870 students and 29 teachers. What is the number of students per teacher? Well, we're looking for students per teacher. So I'm going to start with ST for students over TE for teachers. There's 870 students over 29 teachers. Let's go ahead and do the division. 870 divided by 29. And that should give you 30, which means that there are 30 students per teacher. So we then just calculated the unit rates. Okay, so if you wanted to do the problems in the note-taking packet, the correlating pages would be pages 3 through 4, just the top of the page. We're going to move into constant of proportionality from graphs. So the first thing you might ask me is, what is the constant of proportionality? It describes the constant rate of change between two quantities in a proportional relationship. It's also known as a unit rate, which we just talked about. A unit rate is a comparison of two quantities where one will always be in your denominator. So miles per 1 hour, dollars per 1 liter, dollars per 1 gallon are all examples. The other way we find it, R is going to represent your constant of proportionality, and we would simply just divide y over x. Now I know this all sounds confusing, so let's get to a few examples so you can understand what this all means. So before we do that, how do we tell if a graph is or a relationship is proportional? And we're going to be looking at graph problems. First, when graphed, a straight line is formed. We call that linear. Notice the word line in that. So if something is linear, it means that it forms a straight line. The second thing it needs is that it has to start at the origin, which on a graph, that would be 0, 0. That's the point where your y-axis meets your x-axis, or they intersect. So that's called your origin, which is 0, 0. And then the last thing is y divided by x is the same for all data points of the graph. So any points that are on that line, y divided by x should always be the same, and that's your constant of proportionality. Okay, so let's take a look at this graph. It says the graph below shows a proportional relationship between x and y. What is the constant of proportionality? Well, I can see that there's a point right here, which is at 1, 3.5. As you can see, this falls right in between 3 and 4. So to find our constant of proportionality, we're just going to do y divided by x. And we know in a coordinate like this, the first number represents x, and the second number represents y. So to find our constant of proportionality, or our unit rate, we're just going to do 3.5 divided by 1, y over x. So your constant of proportionality, or your unit rate here, would be 3.5. Lines A, B, and C show proportional relationships. Which line has a constant of proportionality between y and x of 4 over 3? Well, that means that y over x, so that means your y is 4, your x is 3, which means your coordinate would be 3, 4. So I'm going to go and find where that point would be. So 1, 2, 3, and now I'm going to go up 4 units. 1, 2, 3, 4. So that point would lie right there, which means that the line that has that constant of proportionality would be line B. The following graph shows a proportional relationship. What is the constant of proportionality between y and x in the graph? Well, I'm going to take a look at my points here. It's at 3, 2. Okay, remember x comes first, y comes second. So my x-axis is 3, my y-axis is 2. And to find your constant of proportionality, remember that's r equals y over x. So your constant of proportionality here would be 2 over 3. That would be your unit rate. Okay, the next thing we're going to talk about is the constant of proportionality from equations. This is the last skill we're going to talk about in this video. It says, which equation has a constant of proportionality equal to 3? Well, your equation format is y equals rx, where r represents your constant of proportionality. I'm just going to abbreviate it right here. Okay. You might want to copy this equation down in your notes. And then x and y are simply just points on your line, just like on the previous graphs we saw. So really all that's telling you is that this number here is your constant of proportionality. So r would equal 8/5 for this one. In this equation, r would be 1/3. For C, it would be 1/4. And the last one would be 18/6, which if you think about it, 18 divided by 6 is 3. So the correct answer here would be D. Okay, again, I'm just going to write that equation, y equals rx. It says, what is the constant of proportionality in the equation? Y equals 5/9 x. Simply, 5/9 would be your constant of proportionality. Which equation has a constant of proportionality equal to 0.25? Well, we should know that this decimal has a fractional equivalent of 1/4. So obviously A is incorrect because that's the whole number 25 and we're looking for 0.25. If I were to divide 5 by 2, I would get 2.5. So it can't be that one. Here I see 1/4, which means that C is the correct answer. And then here was 1/25, so it's obviously not that. That would be 0.04. So the correct answer here is C. Okay, that does it for the 3 skills today. The correlating note-taking packet pages for the constant of proportionality skills we just discussed are pages 4 through 7 in your note-taking packet. Have a great day, everybody.